السلام عليكم ورحمة الله وبركاته. Okay, Bismillah ar-Rahman ar-Rahim. I would like to remind you of the quiz. The quiz will be multiple choice questions. It will focus on the material I send you in your email. طيب. Try to read it properly. Focus on the major ideas. On the major ideas. Don't go on deep into details. Okay, there'll be no much of details in the quiz. The quiz will be focusing on the major ideas. That's not the details. I will not ask you in the exam how an algorithm will work or how the شو اسمه اللهم صل على محمد how the semaphore works. I will not ask you about programming. I want your basic understanding of the major topics. That's it. Okay. Today's class, most all the questions will be multiple choice, inshallah. طيب. Multiple choice questions. Most probably there will be 20 questions. 20 questions, and every question is half mark. طيب. Okay, today's class we will take a new topic. Through the course, we were talking about the operating system functions. I'm sharing my screen now. I hope you all can see my screen. We were talking about the operating system and that the operating system generally manage all the components of the computer system. So the computer system is hardware, as you see in this figure. So we have a lot of resources that are connected all together with the bus. Okay, the bus is where the bits transferred all over the computer and and make the communication between all the parts of the computer, all the components. So the operating system manages the network, the hard disk, USB, whatever, the main memory, the processor, the monitor, and the keyboard, whatever input and output devices are there, it manages it. So what we were talking about from the beginning of our course are the basics of a computer system, and then the hardware, and then we give you an overview of what is an operating system, also an overview, and then we started talking about how the CPU work and how the scheduler of the CPU, the scheduling algorithms, the processes, the threads, what are the difficulties, problems that are that happen during the execution of processes or threads. Now, today we will talk about, we will start our new chapter about the main memory and how the operating system manage the main memory. As a reminder about the types of memory, we took a lot of types of memory and we were saying that there are some memory types faster than other types of memory. The thing I want you to know before we said this, I remember we gave you some information that the register is the fastest in memory. Okay, and it's the fastest and most expensive. So inside the CPU here, we have registers. We have the registers, okay, which is the fastest. Now, and this is the RAM. The main RAM is here. This is the big one. This is the RAM. Now, the computer architecture developed in order to have more utilization and faster utilization of processing and faster speed. The modern computers, they created something called the cache, and the cache is something that it's not fast as the register that is inside the CPU, and it's not slow as the RAM. Okay, so they created the cache. So there is something called L1 cache and L2 cache, and some computers they have L3 cache. So simply the cache is a type of memory, a type of memory. It's like a big bank of memory. Okay, uh, it's the size is less than the RAM, and the speed is uh, less than the register. So it's a temporary place. So it make the utilization of the CPU more. Uh, and these caches, some of them they are installed inside the CPU, like L1 cache here, and some of them like L2 cache outside the CPU, and there are also L3 cache, the level 1, level 2, level 3, and it varies from computer to computer. Okay, so this type of caches is like it depends on the manufacturer, on the company that create the computer, how they design it. So what we are going to focus in our course, we will not talk about the caches in this complex architecture. We will use very simple architecture. Okay, but I wanted just to let you know that what is happening in the real life in the current computer manufacturing systems, how the real life now they use the caches level 1 and level 2 and level 3, and there are a lot of variations from Intel to AMD CPUs to etc. Right. The material I want to share with you today is for chapter or for part 4, which is talking about the memory management. It's a PDF file, and I found this material very interesting. This guy, okay, Carl, he's from Uppsala University. He created very nice material. I will send you also the website. He got a website with all the materials for OS. His illustrations are very nice, straightforward, simplified. So I'm using his material for the memory management classes. Uh, so what we covered so far, talking about processes, that we have some processes created by human users, and there are some processes that are not interactive with users. They are non-interactive processes with no human use. It's not non-human. So the operating system controls the hardware and coordinates its use among the various applications and programs for various users. And it's not only for the users, also for this type of processes that are not does not interact with a specific user. An operating system provides an environment for the execution of programs. Now here comes the processes that are important to be available to provide the services of the operating systems. You saw all this before, so you know the components of computer system, and this is the same hierarchy we gave you before. We said that the registers here are the smallest. Okay, so it might be like in 512 bytes, and then we have, which is the fastest and most expensive, and we have the cache. Okay, and the cache, okay, it is a small, like up to 12 megabyte, and then we have the RAM that might go to gigas, okay, and the hard disk that might go larger to terabytes, okay, and etc. Okay, large and large. So in terms of speed, the register speed is equals to the CPU speed. The register speed is equal to the register speed, the CPU speed. So it is up. It's in nanoseconds, like in 1 nanosecond. It can be less than that, by the way, but anyhow, we are just giving this example of how speed and cost and size are uh, different according to the level of execution. Um, Now all those يعني the registers, the cache, the RAM here, these are types of memory and the hard disk. So our course يعني our this chapter memory management, we will talk about these things here, and later on, if we have time before final exams, we might go into managing the hard disk and managing the file systems. We hopefully we can cover this also in this course. Now, you remember this uh, state diagram, process creation. Once a program, when we have a program, we fetch the program from the disk. This program is an executable file. We fetch it, yani we copy it from the disk, and we put it in main memory. Now, once we put it in the main memory, it is started execution. It is a process. It is an active program. It is a program in execution. This is the process. So the state of this process will be new, and then it will put in the new queue, and then it go move on the ready queue until it is started executing in the running queue, and maybe to waiting queue again until it is terminated. So this is the states of the process of a specific program. Type. When we were talking about process, it not necessarily a process. Sometimes it might be a thread. So remember, we always say process, 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 but the actual thing in many cases, those are threads. So especially in because many things happen with memory sharing. So anyhow, you can use a process. It depends on the context. But throughout this presentation, we always say process, process, process. We don't say threads, threads, threads. So anyhow, also we gave you information about the process control block. So this block is information. The operating system must allocate memory for the process control block. Also, this block is information, and we need to save it in somewhere in memory. So the process control block, it has data or information inside it. So we want to keep track of it, okay? And it's like a repository, يعني like a bank of information that vary, that changes through the execution of processes. So this is also we need to save it in memory. So the bottom line is we must allocate memory for any new process. So it for any process control block. So the process control block information, we gave you this information before. We have the process ID, process state, the process CPU context, etc., and the CPU scheduling information. Also, there is something important here, the memory management information. This is also, we need to know where exactly this information is saved in memory. So we have something called a process memory space. So we allocate a specific area, space, inside the memory to save the information of the process control block. And we sometimes they call this as the process memory image, process memory image, or the process memory space. This is two the same meaning. Now you know that the memory, the computer memory, the RAM, start from address 00000 to a max number, whatever, FFFFF in hexadecimal. Okay. So it has a minimum number and a maximum number. So every location it has a number. Every location in memory it has its own number. يعني to have يعني a better understanding of this, maybe we should give you, we should see the image in this way. This is the address 00000, many zeros. It depends on how many, okay, and then 1. Okay, this is a simplified way of, yani, so this location is location 0, and this is another location 1, and it go up, the counter will go up, 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 up until we reach the location, okay, 99999, okay, in decimal. But actually they don't use this. They don't use the decimal number. They don't put right 999. They use the hexadecimal numbers. So the last one would be F, you know. Okay, but just up to last one, like this. So there's a lot of locations in memory, and yani this is a simplified illustration. It's not actually in hardware. It's not like this 100%, but we are simplifying things for you. Type. Anyhow, and we said that every process, once we copy the program from disk into memory, and it's new to be executed by the CPU, so it's a process. It's not no more a program. It will become an active program. So it's a process, and the details of the process is copied in this area in the text. So the code, the executable code, is copied here. Okay, again, if we go and see how it goes, so you will see that your program will be copied here somewhere here between 00000, for example. Okay, up to, for example, 500. Right? So from this point to this point, your program is copied from disk to this area. And then once it starts execution, your program will start using this area, data area, heap area, stack area. So the heap will start, for example, the heap is from 600. It will start increasing like this, taking the value. And this is the empty area in the middle. Huh? This is the empty area. Or the stack will start increasing in this direction. Okay, this is a basic illustration of how the allocated memory for a process. So we have two memory allocations for a process. The process control block, we need memory for it, and the program, the code of this process, we need another memory for it. So this is what is happening. A simple illustration, as you see here, that the main memory, inside the main memory, we have memory allocated for the process control block, and we have memory allocated for the process memory image, or we call it the space, the process memory space or the image. Right. Now, once the process state is changed from new to ready, to the ready state, it means it's ready for execution. Then a program, uh, the program copies, the operating system start copying your program instructions from the memory to the CPU registers for execution. If you notice, like I said in the beginning of my class here, my session today, we have L1 and L2 caches. So the main memory here, the operating system will copy from here to the register inside the CPU for execution directly. Okay, but what about L1 and L2 caches? We will not cover in this course. Okay, we will assume that the instructions are copied from the memory directly to the register inside CPU for execution. Just to simplify the course for you and simplify the topics. Okay. But if you add caches, L1 and L2 caches, then things will be more complex. طيب. Now the register access in one CPU clock or less. يعني it's fast. It's as fast as the CPU. Okay. Main memory can take many cycles. يعني depends on the during the execution. The cache sit between main memory and CPU registers. This is I already informed. Now, if we have many processes, we must enforce memory protection. So we don't want multiple processes to to modify the data. Okay, we don't want the multiple processes to change the data in of other processes in memory. So we protect the processes in this way. Right. Now, suppose we have multiple processes like process A, B, C, etc., until process Z. So we need to protect these areas. So this orange area here, the stack, this is dedicated only for process A, and the heap is dedicated for process A, and the data here is for process A, and the text here is the code, the program being copied from the disk to memory for process A, and so on for process B and up to process Z. So every one of them here, this is this rectangles here, every one of these rectangles, this is a memory inside the RAM, yeah, specific memory inside the RAM. So the operating system must have a manager to protect these processes from each other, not to. So this is why if you remember, we said processes are independent. They don't share memory, okay? But threads not. Threads they share memory, okay? So inside the main memory, we will have these many. We are distributing يعني, the main memory into multiple processes. Now we have something called single contiguous allocation. يعني next to each other. يعني the processes, all the processes will be next to each other. Contiguous يعني next to each other. طيب. Single allocation is the simplest memory management technique. That's it. Yani we put every process next to each other, and this is the simplest way. This was done in old operating systems like the MS-DOS. Okay, they allocate memory in this way. Also, some embedded systems are running in a single application might also use this technique. So the single contiguous allocation technique can be done by these systems, the MS-DOS system and the embedded systems. طيب. Okay. A process can be swapped temporarily out of memory to a backing store and then brought back into memory for continued execution. Now, so these processes, we might have 5 processes running. We might take one of them and we swap it. So we replace it with another process, or so this type of technique, we have a backing store, يعني place where we can store the data of the process. So this is a fast disk large enough to accommodate copies of all memory images for all users. So it's like a disk that copies everything, all the process we are. So we can roll out or roll in. While swapping, we roll out, يعني we take the process from the memory and we put it in the disk. Roll in, we take it from the disk and we put it in the RAM. Um, so the swap problem is it's يعني transfer time. So it takes too much time. Okay, well, why we need swapping? We need sometimes swapping because maybe the memory is not enough. So we now need to take part of the disk for this. طيب. So this is the backing store. This is a disk. So we swap out. We swap out and we take it from the RAM and we put it in the disk. Swap in, we take it from the disk and we put it back into the RAM. So when we say the RAM, the processes are in the RAM, we mention the user processes, not the operating system processes. The operating system processes we don't touch. Okay, we mention the processes done by you as a user or a programmer. Okay, طيب. We have the term memory resident. It's like staying in memory. So certain program can be marked as being memory resident, which means that the operating system is not permitted to swap them out to storage device. They will always remain in memory. Okay, so this is important. Some processes, because they are critical to the system, important, they must not be slow. They are called memory resident. So they stay in memory all the time. Okay. Also, we can have a location partitioned. So we divided into parts. So the primary memory is divided into multiple memory partitions. Okay. Uh, so we allocate it in this sense. So every part might have all the information for a specific job. Okay. And usually they are contiguous, يعني next to each other. Okay. So this is an illustration of a main memory, usually divided into two partitions, one for the operating system and one for all the processes in the system. And this we saw it many times. So usually the operating system processes are resident, يعني they are not swapped to disk. And usually the user processes, they are the ones might be swapped into the disk. Okay. So whatever the addresses in memory that are near the resident area here, we call it low addresses. And whatever our addresses are for the user processes, we say this is a high address. So a logical address space is the address at which a memory cell appears to reside from the perspective of an executing application program. So we call this a logical address space. So this is an example. As we said, we have a process control block and we have the process itself. So the process with its code here, it must have a specific area in memory. So this is start, for example, in this area here, 120,900, and it stops here at 300040. So this is allocated area for this process. And what about the process control block? The process control block, he got this information saved inside he saved the process ID also. He saved all this data, and he will save this information that this process here, it will start from this address to this address in memory. Okay. So these two pieces of information in blue, we save it inside the memory management information inside the process control block. And this all block here, it is saved also in memory, in memory, but it will be saved inside this operating system memory. This is dedicated for the process, the operating system. A pair of base and limit. So these two pieces of information, this number and this number, this one here we call it the base, and this we call it the limit. So these two, a pair of base and limit registers, define a process logical address space. So the logical address space is simply two numbers. One we call it the base, and the other number we call it the limit. And in between them, we are saving the process data. Okay, the code, the heap, the stack, etc. Okay, all this process image. And these two numbers, base and limit, both of them, they will be inside the register. They will be inside the CPU register for execution once if we decided to execute this process. Right. So this is the low addresses and the high addresses we mentioned in the main memory. Okay. And this is an example of an Intel CPU. So what will happen is if you have a process here, process 1, so it is inside the physical memory, and process 2 is inside the physical memory, and process 3 inside the physical memory. Once we need to execute process 2 inside the CPU, now it will go the details of it from address, for example 0 to whatever address, we take it inside the CPU. So it is a logical memory address that represent what instructions we are going to execute in CPU from which address to which address. Last thing I want to mention here is the memory management unit. And in the memory management unit is a computer hardware unit having all memory references passed through itself, primarily performing the translation of logical memory addresses to physical memory addresses. From memory to, so this is the main memory. We have this MMU unit. Okay, we take this physical address, whatever this physical address from memory. Okay, and here we for every separate value of each process, we take this number so that we know where we are going to what we are going to execute. We start from 14000, and we have this number 14346. So this is like we start from 14000 and we add, for example, 364. So the total is 14,346. So this is the addresses in between where the CPU going to execute. So this is a simple MMU for partitions contiguous allocation. So all processes, we assume that they are adjacent to each other, they are next to each other. So this is the simple way. But the point here is this is the same thing about the limit and in between numbers. Okay, so the problem we are facing now is we have not always adjacent. So we have my process 5 here, process 8 here, and process 2 here. So these processes are adjacent to each other, next to each other, whatever this is called. Okay, but here in this example, we have a hole, we have a free space between process 5 and process 2. And here we have another example. Let's say in this example here, process 5 and process 2 is still running, and process 8 is terminated. So there is a hole. There's nothing there because it's terminated. And this is another example here where process 9 allocates part of the hole left by process 8. So a new process will come in this big hole here, and we have a new process, process 9. It came inside this big hole. So it allocated this area, but still this area is not, it's free. If a new process that like process 10 came inside, So it's still, we have a small, the hole is getting smaller and smaller, but we have still a free space here. So the operating system must manage these kind of scenarios and not to make many holes. You know, we need to have efficiency of memory management. We want to manage the memory, so we don't need to have many holes here, and we have to minimize the holes as much as we can. So this is the topic we going to cover, and we will look into algorithms, how the operating system, inshallah ta'ala, will utilize the memory so that we don't need big holes here, and we allocate partitions so that there will be less free spaces in memory, and we don't have waste of space in memory. So inshallah ta'ala, by next class we will start to talk about how these allocations and what are the problems. So like the first fit and best fit and worst fit, we start from here inshallah ta'ala. Okay, sorry we took more time from your the class today. Okay, I'll take the attendance quickly now. Right, still if you are trying
دكتور
to study for the quiz and you're still facing problems or you have any questions, you can send me a WhatsApp or email. I'll try to answer your questions as soon
دكتور
as I receive it. طيب. Okay, I took the attendance. Your
دكتور
ايش هذه؟ مدينة. كم راح نختبر كويز؟ كم ناخذ؟ I think I answered these questions. We will take 20 questions. Every questions half mark. All of it are multiple choice. Please focus on the main ideas, the basic ideas, the important ideas. Don't go in the details. I will not ask you how any of the algorithms work, how the algorithms are working. Will not ask you about programming or coding. Okay, I will just ask you about the يعني the major ideas, the important ideas between these. I don't know who raised the hand. How many quizzes we'll take? Well, I remember it's three quizzes, so three or four maybe. So anyhow, this is the second one. I think I send you the our plan. This is the course plan. Okay, so how many quizzes we have? Quiz four quizzes. Okay, four quizzes. تمام. Best three. Well, I'm not sure. I'm not sure. Well, I don't know. I will check with the coordinator to make to be very sure with it. I'm not sure. طيب. Okay, enjoy your day. Study well. Have a good iftar inshallah today. See you next class. Assalamu alaikum wa rahmatullahi wa barakatuh.